Hi guys, it's Dr. G and welcome to WTW Science. It's that time of the year where everybody's trying to shed mass. Well, they call it weight loss program. It can be a really difficult and emotionally challenging time. Is it weight? Is it mass? Is it kgs? Is it pounds? So here I am just ready to take my reading. I've got a scale here and it's calibrated in kgs. So let's look for that magic number. So what I'm really measuring right now is just my body composition, all the atoms making up my body, and that reads a whopping 93.3 kgs. I'd like to minus the mass of the tachys, so that'll give me at least 92.3 kgs. And I should remind you, this is mainly muscle. Just a brief, not even a lecture, just some information regarding mass and weight, because these concepts are used every single day. So on one hand we have mass of an object, and we know that the mass is measured in kgs. And if you had to ask me, sort of very simple term, what mass is, it's really the stuff that you made up of. Okay, and scientists would refer to this stuff as little bits and pieces called atoms. So all matter has mass, and we can break down this matter into these simple blocks or building blocks called atoms. What about weight? Because we're always going on a weight loss program as opposed to a mass loss program. So what is weight? So weight, firstly, is a force, and it's measured in newtons. Newtons, named after the guy who supposedly sat under an apple tree and discovered the law of gravity. Now, in order to think of weight, try to imagine yourself standing on the surface of the earth. And so the weight here would really be the force at which the earth attracts you to its center. Okay? And there's a formula for that, and we're not going to get too constipated here about formulae. But this one's pretty straightforward. So the weight of an object is equal to the mass of the object, m, times this little constant g. And depending where you are on the surface of the earth, we could take g to be approximately 10 meters per second squared. Meters per second squared is a unit of acceleration. So if your mass is 50 kgs, then your weight can be calculated as 50 times 10, which is 500 newtons. That would be approximate weight on our planet. Now, if I had to transport you to the moon, your weight will actually be much lower. And the reason for that is pretty straightforward, and that is your mass cannot change, so you still be 50 kgs, that's the stuff that you're made up of. But what will change on the surface of the moon is the acceleration due to gravity. It's approximately 1/6 that of Earth. So the weight, your weight on the moon would be the weight on Earth divided by 6, approximately. All right. So that's pretty clear. So when we speak of a weight loss program, what we really intend doing is to actually lose the mass. But because it's so intrinsically connected, W is equal to mg, people actually use this interchangeably, referring to weight loss rather than mass loss. Okay, there is one more concept that people find quite confusing, and that is the concept of density. Okay, so you may have asked the question, a little pebble sinks to the bottom of a pond, but a massive ship stays afloat. Well, most ships. So how is that possible? Well, the concept of density is related to mass, which we just discussed, the stuff that an object is made up of, and it's also related to the volume, or what I would like to call space. So the density of an object is nothing more than its mass divided by the volume. And you may have come across the concept of the density of water, which happens to be 1 gram per cubic centimeter. So I would like to do a few experiments there just to illustrate the concept of density, and that will make things much clearer in terms of mass, weight, density, and put into perspective what one means by going on a weight loss program. Hi guys, this is part 3 of our investigations into mass, weight and density. Now we've seen many of these experiments on YouTube and also on TV. Coke Light versus Coke, you know, dunk them into water, which is going to float, which is going to sink, and the common thought there is that the Coke Light will float and the Coke will sink. Let's just go back to the earlier concept of density. We said that density is mass divided by volume. So each of these cans are 330 mils. Each of the cans are 330 mils, so they're identical cans, identical volume. All right. So if the Coke Light had to float, that means its mass has to be slightly lower than the mass of the classic Coke. And that is true because the classic Coke has sugar, whereas the Coke Light has no sugar. So there's a big difference in terms of the mass brought about by the sugar in the classic Coke. So it's very simple to demonstrate this. Let's just pop each of these cans into water and let's look at the verdict. So as expected, we notice that the Coke Light actually floats to a certain degree. The classic Coke sinks to the bottom. There are other factors involved here, that is the temperature of the water as well as the density of the water. That can be changed by adding salt or sugar to that. But here we have it, you know, the classic Coke having more sugar in there sinks to the bottom, and the Coke Light having no sugar floats while immersed in water. So excellent. Okay guys, so further to our investigations into density. So it's not always the density of an object that gets it to be buoyant in a fluid like water. So here I have a classic case, a lime itself, very small, a smaller weight, and a large lemon itself. And if you use your common sense, then most people would say that the bigger object will sink and the smaller object should float because of the mass difference. Well, nobody's really got by with common sense. So try not to use your common sense as far as possible. I know your parents would tell you, your teachers would tell you, but no one's really produced anything new and exciting by using the common sense. So let's just pop this in. So the first thing I want to do is drop the little lime in there and just observe what happens there. So you notice that it sinks all the way to the bottom, and a lot of you are hoping that you would be right with the larger lemon with the larger mass sinking to the bottom as well, and well, it goes against all the odds and start to float. So what's really happening there? I mean, is this a magic lemon versus magic lime, or really the magic of science? Well, if you think about this very carefully, the lime itself has a very thin peel, or what we would call rind, okay, as opposed to the larger lemon, which has a thicker peel. And in the thicker peel, there's lots of air pockets, and the air pockets actually create this buoyancy. Think of yourself in a pool using those armbands. When they're fully inflated, you have the ability to become more buoyant as opposed to deflated armbands. So that's the principle here, the whole idea of buoyancy and Archimedes' principle. So that's basically what you want to have a look at as well. Right, so leading on from the lime and lemon saga, so here's a beautiful demonstration which illustrates not the use, but the effect of the rind or the peel of, in this case we're using an orange, on the buoyancy of an object. So I have a completely peeled out orange without the peel, partially peeled, and then essentially an unpeeled orange. Now if you look at this just at face value, the one that's not peeled you would say has a larger mass. But we're not talking about mass here, we're not talking about volume, but we're talking about the classic concept of density. So let's pop these in and let's basically figure out which one's going to float. So the first thing I'm going to drop is the completely peeled orange. And as you would expect by now from the previous experiment, the completely peeled orange would be totally submerged and sinks to the bottom. Partially peeled orange, well, we didn't peel that enough, but you notice that it actually floats quite nicely. Completely peeled, which is obviously the most massive one, also defies common sense, and that's basically floats at the surface as well. Alright, so here's a classic case of density, mass, volume, as well as the air pockets producing the buoyancy to enable these objects to float. I'm hoping that this video has given you some insight into mass, weight, and density. You know, when you're embarking on a weight loss program, it's not just about training, it's not about eating correctly, it's also about having the mind, the will, to keep at it. Many of us embark on what we call a Monday morning diet syndrome. You know, every single Monday you start a new diet, and I think with the correct willpower, the right mindset, of course diet and training, you can achieve your goal. Anything is possible. Thank you.